Hello everybody, we're getting ready to do lesson 8.4 part 2 of pre-calculus math today, classwork. And for today's classwork lesson, part 2 of 8.4, the binomial theorem, you will have 8 points that will go into your notebook or your notebook guide. And then you got 42 points that will go onto your classwork sheet. Students, please put your name, date, and period. And if you're online or a homeschooler, please put your due date here. We go right into a classwork here, part 2 of 8.4, expanding binomial expressions, example 5. Write the expansion of each expression. So here is our expression, 2x minus 3 to the 4th power. So the binomial coefficients are, here they are, 0, 1, 2, 3, and 4. And they're 1, 4, 6, 4, and 1. Those are your coefficients for this expansion. And therefore the expansions are as follows. Here's your expansion, 1, 4, 6, 4, and 1. And then this is 2x to the 4th, 2x cubed, 3 to the 1st, 2x squared, 3 squared, 2x to the 1, 3 to the 3rd, and then 3 to the 4th. And then that comes out to this expression here, 16x to the 4th minus 96x cubed plus 216x squared minus 216x plus 81. That would be this expansion here. And then for b, x minus 2y to the 4th. How would we do that? Let's find our coefficients for that. So x minus 2y to the 4th. Here's our expansion here. We go 0, 1, 2, 3, and 4. And that will result in 1 times x to the 4th, 4 times x cubed 2y to the 1st. And then 6x squared 2y squared minus, and see our signs here, they're alternating. And then 4 here would be our second to last coefficient, be 4x to the 2y to the cubed. And then we have 1 to the 2y to the 4th power. That would be our expansion of this. And then this would be your expression. This would be your actual expression here for the expansion of this binomial. So by graphing the original binomial, by graphing this, graphing the original and the expansion, graphing this and then this, you should get the same graph. Okay, let's try one here. Use the binomial theorem to expand and simplify this expression here, 1 minus 4x cubed. Students, this is yours down here, pay attention. So for this one up here, we have a cube. So for that we have 1, 2, 3, and 4 expansion starting with 0, 1, 2, and 3. And then when we do that, this becomes 1. This is 1 minus 3 here times 4x plus 3 times 4x squared minus 1 times 4x cubed. And then when you simplify this, you come up with 1 minus 12x plus 48x squared minus 64x cubed for this expansion here. Into our next example, expanding a binomial. Write the expansion of this expression, x squared plus 4 quantity cubed. So expand using the binomial coefficients from example 3. So remember back to example 3, we have a cube here. So go 0, 1, 2, and 3. And then here's our expansion here, if you remember that. 1, 3, 3, and 1. And then x squared squared 4. Then x squared 4 squared. Then just 4 cubed here. And this would be x squared cubed here. And then this would be x squared squared here. and those were coefficients already predetermined in example 3. And then when we simplify this expansion here, we come up with x to the 6 plus 12x to the 4th. 4 times 3 is 12x to the 4th. And then we have 48. This will be a 16 times 3 is 48, x squared. And then 4 cubed to be 64. Okay, let's do this one. Use the binomial theorem to expand and simplify this expression here. So this is our binomial. Students, this is yours. Beware of that. So up here, okay, so here's our initial expansion. 0, 1, 2, 3, and 4. And then when you expand this out, you have x to the 8th, 8x to the 6th, c the 4. So this would be 8x to the 6th. And then this would be c4. This would be 6. 4 times 6 would be, wait a minute. 4 times 6, yeah, this would be 24, x to the 4th. And then this here will be 8 times 4, be 32x squared. And then this would be 16. This would be 1 times 2 to the 4th would be 16. Sometimes you will need to find a specific term in a binomial expansion. Instead of writing out the entire expansion, you can use the fact that from the binomial theorem, the r plus 1th term is signified by this, NCR x to the n minus r, y to the r. So n minus r, there's a key. For instance, to find the third term of the expression in example 6, you could use the formula above with n equals 3, and then r would equal 2. You could do that. To find your third term here, you plug in 3 there, and then r would be 2 for that, n 3 and 2. So when you plug those numbers into this formula here, you come up with 4 squared. This would be 4 squared here. Wait a minute. C3C2 times 4 squared, so it would be 3x squared to the c x squared, and then 3 minus 2 would be first power, it would be 1 there, then 4 squared, and then when you simplify this, you come up with 48x squared. That would be your third term in example 6. So now we're going to try one. I'm sure we are. Finding a term of coefficient in a binomial expansion. Find the sixth term of this expansion here, a plus 2b to the 8th power. So because the formula is for the r plus 1 term, r is 1 less than the number of the term you need. So to find the sixth term in this expansion, use r equals 5. So, okay, that's good to know. So n equals 8, x equals a, and y equals 2b in this expression up here. So now we have all of our terms. Here's our formula. Then we plug in 8c5, 8 to the a to the 8 minus 5, 2b to the 5th. That will give us our sixth term here. And then when we simplify this, this comes at 56 times a cubed times 2b to the 5th. And then 56 times 2 to the 5th, a cubed b to the 5th, and then this comes out to 1792 a cubed b to the 5th. So you just plug in your terms and you crank out your sixth term of this expansion here. B, find the coefficient of the term a6 b to the 5th in the expansion of 2a to the minus 5b to the 11th. Now we're going to find the coefficient now of this term here from this expansion here. How would we do that? Note that 2a minus 5b to the 11th equals 2a plus the negative of 5b all to the 11th power. Knowing that, we have n equals 11, r equals 5, x equals 2a, and y would equal negative 5b here. So r here, we're trying to find the expansion of this here, a to the 6th, b to the 5th. That determines that this would be r equals 5. Okay, so knowing that, substitute these values to obtain, here's our formula, NCR x to the n minus r, y to the r, and then we plug in our values here, 11, and then see r here will be 11, 5, and then 2a to the 6, 2a, see 2a here to the 6, n minus r, so n minus r, find the coefficient here, n minus r, and then negative 5b would be our y here, negative 5b to the 5th. See, here's our r here. Our r shows up here, and then it shows up here implicitly in there. Okay, so once we get to this step here, we take that out, and we come up with this figure here. And there again, we're back to that. And then when we crank this out, this is 462, 64a to the 6th minus 3125b to the 5th. Simplify that further, and we get this honking number here. So the coefficient is this, negative 92,400,000. Let's try one now. Find the specified nth term in the expansion of this binomial here, x plus 8 to the 10th. And then we want to find the fourth term here when n equals 4. And then down here, students, this is yours. Now you find this from a specified term. Go back into your classwork, go back into your notes. We're going to do this one in class now. So x plus 8 to the 10th, n equals 4. So to solve that one, again, we just use our formula and we plug in here. 10c3, x to the 10 minus 3, 8 to the 8 cubed. Here's our y here. And then we just crank this out and we get 120, 120x to the 7th. 512 equals, here is your, what are we trying to find the nth term. So it would be, n4 would be 61,440x to the 7th by using that formula. Oh, snuck that in. I shouldn't have done that. Go back until get the video, students, if you want your answer there. Okay, Pascal's triangle. There is a convenient way to remember the pattern for binomial coefficients. By arranging the coefficients in a triangular pattern, you obtain the following array, which is called Pascal's triangle. This triangle is named after the famous French mathematician Blaise Pascal. Then here's your triangle here. So 4 plus 6 would equal 10 here. So 4 and 6 equals 10. This is an example here of how this works. These are your coefficients here depending upon the size of your expansion here. 0, 1, 2, 3, 4, 5, 6, and 7 down here. 1, 2, 3, 4, 5, 6, 7. So knowing about Pascal's triangle, the first and last number in each row of Pascal triangle is 1 here and here. Every other number in each row is formed by adding the two numbers immediately above the number. Pascal noticed that the numbers in this triangle are precisely the same numbers as the coefficients of a binomial expansions as follows. So here's your expansions here, by the way. So row 0, 1, 2, 3, 4, 5, 6, and 7. And then here are your coefficients, depending upon the row here. Isn't that cool? So basically, it's like a calculator for binomial expansion triangle. So again, here is that expansion. The top row of Pascal's triangle is called a zero row. So this is your zero row because it corresponds to this binomial expansion here. Similarly, the next row is called the first row, which is here. because it corresponds to the binomial expansion x plus y to the first power, 1x plus 1y. So this would be 0 row, first row, second row, third row, etc., etc. In general, the nth row of Pascal's triangle gives the coefficients of x plus y to the nth power. So let's try another one. Using Pascal's triangle, use the seventh row of Pascal's triangle to find the binomial coefficients. So here we go. Here is our seventh row here, and we have 8s out here in front, and then this would be your coefficients for your 8th row here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. So again here for 1, so for 8 here we go 1 and 7 is 8. Then for 28, 7, 21 is 28. 35 is 21, 35. 70 is 35, 35. 56, 35, 21. 28, 21, and 7, and then 8 again is 7, 1 is 8, and then 1 would be 1 and 0, I guess, out here, 1 and 0. And then when we plug this in, we have 8, 0, 8, 1, 8, 2, 8, 3. So these are the calculations from 8 choose 3, 8 choose 2, 8 choose 4, etc. And this will be your seventh row. Remember, we start with a 0 row. So we go 0, 1, 2, 3, 4, 5, 6, 7, and then 8 down here. Okay, use Pascal's triangle to find the binomial coefficients. So 7 choose 4. Students, this is yours. 6 choose 3. So for 7 choose 4, using Pascal's triangle for that, so the fourth entry of the seventh row would be a 35. So if you cite your Pascal's triangle, you can easily see that. And that is 8.4, part 2. Here's my email for questions, course materials, animatedpowerpointmathvideo@AOL.com. Thank you very much.